surface, and how is this has to do with the vast darkness of the sky that we see at night? Why is the sky dark at night? Of course there is no sun, but even during moon's daylight the sky is dark. There is no why Earth's daylight has this light blue that we see is because of the atmosphere. But let's take things from the beginning. We live on a planet called Earth, 3 planets from the Sun in our solar system. The Sun with another 200 billion stars from our galaxy, while our galaxy is one among the trillions of galaxies that form the observable universe. To measure those large distances, we use the unit of light year, which is how many years the light need to cover those distances. So after that, let's return to our topic. It was 1823 when Heinrich Olbers, a German physician and astronomer, came up with an interesting paradox which will later be named as the Olbers paradox. At the times of Olbers, the universe was believed to be static, neither expanding nor contracting, infinite in space, without end or boundaries, and eternal. So what Olbers thought was that in such model of the universe the sky should be bright and not dark. Let's see why this model of the universe leads to a bright sky. In an infinite universe there is an infinite number of stars. Let's divide those stars in cells and assume that the universe is homogeneous. The cells has one unit distance between each other, and the number of stars in each cell increases proportionally to the square of the distance. And as we know, not only from the equation of brightness, but also from our everyday experience and common sense, the brightness of one light source in close distance, the brightness of 4 light sources in greater distance, and the brightness of way more light sources in very long distance would emit the same brightness from the observer's view. But since the cells get closer to infinite, brightness would as well. Now wait. Someone would say that this is partly true because the light from the distant stars hasn't reached us yet, so we cannot see those stars. Is that right? No, it's not. Remember that we're talking about an eternal universe, and as it exists for forever, the light from the distant stars has already reached us, and as a result the sky is bright. So, static. What's the point of that characteristic in the paradox? We have already proven that in an infinite and eternal universe the sky should be bright. Well, there is a point in it. Light waves behave like the waves in the water. In an expanding universe, the expansion increases the wavelength, and as a result, it becomes invisible for the human eye as it goes off the visible spectrum, which is the wavelength that humans can see. In a static universe, though, the wave reaches our eyes without any transformation. In this case, we could see the distant stars, which leads us again to a bright sky. But again, what if one said that there is dust that absorbs the light from the stars, or someone else said that the universe isn't really homogeneous, so there are stars that hide behind one another, and we receive less light? Well, the first assumption is just wrong. The dust will not prevent us to see the stars, on the contrary, it would radiate too. So the second assumption may be stars that hiding behind one another, but this would lead to a dark sky with extremely light points, since not all stars can hide behind one another. So to conclude, the paradox states that the static, eternal, and infinite universe would be bright rather than dark. But as far as we know, our universe is neither infinite nor eternal nor static. Big Bang Theory declines all of them because it claims that the universe has a start in space and time, and that it's expanding with accelerating range. Big Bang Theory is the answer on why the sky is black and the solution to the Olbers